So far our simulation was without any tools, so we have been moving our machine without any tool change. So the next thing that I would like to add here is to add the tool change based on what you've seen in the basic training already, using the AnyController capabilities to actually create a tool instance and attach it to the spindle and then move around with it and do material removal. And we will also configure the required changes in the MCF file. To do that, I will first of all modify my ANSI program, remove of some of the stuff that I do no longer need. Actually, we can leave it. Doesn't play a big role. So the typical tool change in most controllers is a T command with a tool number, and then a M6 that actually executes a tool change. I will write it in 2 lines just to see the difference. The difference between T and M6, or why do you need two commands, is on the T command, the machine, and in this case our milling machine, that's a tool pre-selection. So it basically tells the controller which tools should be used next. And what typically happens is, as soon as you activate T, it could be that the magazine behind the door here, for example, starts to rotate and try to locate the tool and to position it in the magazine accordingly, so that if the actual tool change is triggered upon the M6, that the tool is in the right place and you do not lose time. So that's a tool pre-selection. So what you very often find in high volume production is T1, then the actual tool change, and then you will find a T2 again for the next tool, and somewhere later you will find another T2 with M6. So this basically means you do a tool change for the first tool, then you do a tool pre-selection for the second tool, so that it is, and then during the next motions the magazine has time to actually prepare the tool, and then if the actual next tool change comes, it is already in the in the correct position and you do not lose any time. So that's just a remark on what you can find in many programs. But first of all, we want to get our tool change being done. So what happens if you simulate that is, I'm not going to show it, but upon the T command, of course, you will get an error message that CSE needs a metacode for the T, and we will do just that. So I go to Machine Configurator. T I would also put into the Addresses section, select Addresses, select the T, and also here in the tooltip you get already a description that this is the tool selection with an example. So I will do that. I will sort it some here so that it's in the correct order. Here it's correct. So that's the T command. And then we want to customize that. Actually also the T command, similar like F or X, has a value, so the number of the tool or the name of the tool will be stored in this value. If you remember it from the basic training, in the end our M6 will actually do the tool change, so here we need this information which tool is pre-selected. So the T command doesn't do much, we just have to store which tool should be used next. So we need a mechanism to store information so that we can reuse it or read it in the M6 implementation or in the M6 subprogram, AnyController subprogram. We need to store it. One method to do that would be to use a global variable, but that's not very nice. The best way to do that is to use the same mechanism that the machine uses. And if you look up the Siemens documentation, and you will find that in most other documentations as well, the Siemens has a specific manual that lists all system variables, and system variables are always exist on the machine, so you always find them. And they are also used on the real machine to store information. So for example, I know the name of the variable. So for example, the variable $p tool P contains the last program tool number. And that's a number from 0 to 32,000. That's the number of tools that the Siemens controller supports. So we will use this variable to store the information which tool should be used. To do that, we need a new section in Machine Configurator, the variables section. So in order to be able to use such a system variable and store values, you need to define or declare it, and that's done in the variables section. It has two ways to define a system variable, a typical one and a global one. The difference is global means if you should have a machine with two channels, this variable will be available in both channels and it will have the same value in both channels. So if you assign the system variables with the value 1 in channel 1 and you get the value in channel 2, it will also be 1. Since for the tool change it makes sense to be able to use different tools in different channel, for sure the variable will not be global. So I specify the name $p tool P. Then I need to select the type of variable, and in this case that's an information that I get from the documentation. So on the Siemens that's integer. So I'm selecting an integer variable and then it's defined. By default, CSE initializes new values or new variables with a value of 0. So now I can use this variable, and what I will do in the T meta code to customize it, execute and add a command, element child name, and then let's look up in the CSE documentation. It has a whole section that deals with variables, and there's a command called setVariable with variable name and value. That's what we need to store system variables. So the name of the command is setVariable, then a parameter, and that is $p tool P. The variable name is a string of type string. That's why you need the quotes again. And then the value is actually what we get from the T command. That's it. So now we have stored this variable value. So let's close it and save it. And then let's see what happens if we simulate our NC program. I hope I've saved it. And then we can simulate it. So T1 is now executed. Hopefully we have stored the value. And now M6 does do nothing. By default, that's a special thing that we have for Fanuc, Heidenhain and the Siemens controller, that at the moment and up to NX7.5 M commands are automatically ignored. So although you did not specify an M code in the MCF file, all M codes are ignored by default. In case of the tool change, that's not what we want, so we need to change that and add an implementation for the M code. So we need an implementation for the M code. So I go to M codes, add one. In this case it's also an M with an integer behind, so M6. And what I can do next is to call a subprogram. That's a new functionality that we can use, call program. The program that I want to use is something that I will just create. So I will create a subprogram folder. and add a program here that's called tool change dot, if you want, SPF, like the typical Siemens subprograms, but the extension doesn't play a role, so we can also call it TRG. Doesn't matter. So then we have a subprogram, and this one is that we want to call. So I'm selecting the program here. Library, machine, installed machine, Simo8, CSE, Cinemeric, subprogram, tool change. So that calls the subprogram tool change. I want to save that. And then we should add something to our subprogram so that we can see it. So that's my tool change subprogram. So what do we want to do here? In the tool change, we typically go to any controller, switch to any controller. After the end of the tool change, we switch back to Siemens native language, and then we need to do something. First of all, I would like to test if it works in principle. That's why I'm not adding any additional code here. So the MCF is saved, and let's simulate it again. And in this case, T1 is of course unchanged. To be able to see what happens if I execute M1, I need to select the step in mode so that I can step into the subprogram, and it seems to work. So my subprogram handling in principle seems to work, and of course now I need to add the code to actually do this, do the tool change. So I'm going to my tool change subprogram. First of all, I will define an integer variable for any controller, and tool ID, for example, and then I will use get variable to get access to the value of my $p toolp variable. That's the one that holds the value from the T command. So now I have the name of the tool. What I can do next is to check if a tool has been selected. So if 0 or if nTool ID not equals 0, then I need to do generate tool, and the name of the tool, which is nTool ID. Actually, I need from the CSE documentation, I need get tool name by number. So I have a number of the tool and I want to have the tool name, so that's why I need this method. So I should do that up front. String as tool name, as tool, I can do that here, as tool name is this one, and then here of course as tool name, and the name of the spindle, which is typically S in my machine model. I've generated the tool. And if then we need if get next tool then we do grasp get next tool. Get spindle objects from the spindle. That's basically the junction that we would like to attach to. So get next tool now takes the internal name what was produced here with generate tool, and we attach these generated instance of the tool and attach it to the spindle object. Since it's by default invisible, we need to change the visibility. And then here I can copy the name of the tool, switch it to on. And then we want to activate next tool. That's it. I should already do the section for if a tool already exists, I need to remove it. So this is the AnyController method to find out if a tool is already mounted to the spindle or to the given spindle. And in this case, I want to do a release. And probably before that a visibility. So if there's a tool already in this spindle, I switch it invisible and then release it. And for the next tool is defined whenever generate tool was activated. If this exists, I'm attaching it to the tool mount junction, switch it to visible, and set it as the next tool. That's it. That's what should happen in the tool change subprogram. We could have copied the implementation from one of the other samples and modify it, but that's probably a good practice to repeat. Here's a typo. That needs to be string. Let's see if that works, or if there are more typos. This is not going to work. Unable to generate tool. I have not defined a tool, so that's why it's difficult to find one. So I should generate a tool. Any one. The size is okay. CSE queries for this number. So if you do get tool by number, that's the values that we query. So you should enter a number here, otherwise we can't find the tool. Okay. Now it should find the tool. I would like to see what happens, that's why I switch into step in. In this case, the generate tool works, or did something. So there's no current tool, that's why we skipped this section. And now there will be a next tool. We did generate tool before. We grasp it. Then we switch it visible and we activate it. And then you see here as an active tool which tool is being used. And then switch out, and now we can use that tool. That's it about the tool change.